Okay, we're going to move on to our first year 13 unit, and we're actually going to start with M5. I know there's an M4, but I think it makes more sense to do it in this order. This will fit more with what we've been doing recently, and then we'll go back and do M4 in a couple of units' time. The first section is on resolving forces, and basically resolving forces is all about taking a two-dimensional force where they give you a magnitude and a direction, and cutting it down into that vector format. So if we have a look at the first question, example 1, you've got two forces in it. It says find the component of each force in the x direction and the y direction. So very simply put, if we've got a force that goes off at the diagonal and an angle here and a magnitude of the force, again we did in the sort of year 12 mechanics we just finished, we looked at if we had the I and the j and then working out the magnitude of the force and the bearing at which it went. But here we're trying to go backwards, so we're really looking at what this force is and what this force is, so that we can think of it in its two component parts. We can think of it as a horizontal part and as a vertical part. And we can do this using our trigonometry, right? So if this is 9 here, if I write 9 here just to be clear, that's that side. It's a right angle triangle. So if we're looking for the horizontal force, and we'll use this notation, so if I do an arrow to the right, it means that we're looking for the horizontal direction of the force to the right. It's going to be 9, well it's going to be we've got that cos 40 equals the adjacent over the hypotenuse, so this is cos 40 equals the adjacent over 9, so it's 9 cos 40. Okay, and obviously we can put that into a calculator and work out what the value is. 6.9 newtons to one decimal place, or two significant figures. We can do similarly for the vertical direction, right? Except this time, so the vertical component of the force is this one here, and instead of having cos 40, we'll have sine 40 equals opposite over hypotenuse. So we're going to get with 9 sine 40 equals 5.8 newtons. And actually, what's going to happen is that well, actually, let's just finish this question off. So we've got that this force here, we're going to write it in the vector format. So we've got to the right, which is the I component, we've got it's 6.9, so it's 6.9 I, and then to the j component 5.8 j, and they're obviously both positive in those directions. So that'll be your final answer for part A. Very quickly, we're going to get a rule out of this that we're going to use throughout the whole of the year 13 mechanics here. So we can see that here we've got 9 cos 40 and here we've got 9 sine 40. And if we go back to the original diagram, we can see that any time, what's going to happen is any time that if we look at the magnitude of the force, if we need to move to the horizontal and we move through the angle, it's going to be 9 and then it's cos 40, right? So anytime it's through, we're using cos. On the other hand, right, anytime we move away from the angle to go to the vertical, so the 40 is not there, we've gone away from the angle, this is 9 sine 40, and the key there is that it's sine. And those rules are going to be really, really important. We're going to use them repeatedly, so you will get used to them. And that just saves us having to do this whole triangle every time, because we can write it down straight away. Let me show you what I'm talking about in part B. So in part B, I look at my diagram straight away. And I would like to resolve it. I'd like to know the vertical component and the horizontal component. And this time it's going down. So I'm just going to do this down. I'm going to remember that I've gone down when I come to doing the sine of it later. But actually, if we want to resolve it, we look at the diagram, we've got 100, and then we look at what movement to get from that 100 to the vertical. And this movement is that we go through the angle. If we go through the angle, right, that tells us that it's going to be cos. So it's 100 cos 18. Obviously we pop that straight into the calculator, which is 95.1 newtons. On the other hand, if we want to resolve it to the left, because it's also going to the left, right, we look at it again and we see that to the left is actually going to be going away from that angle of 18 degrees. And again, if it's away, and this is always going to be the same, right, if you go away from the angle and you're trying to resolve in that direction, it's going to be sine. So here it's 100, but this time it's sine of 18. 100 times sine 18 is 30.9 newtons. Okay, so it's much quicker than actually drawing the triangles out, and it's a way of that will stick for us all the way through. If you go through the angle, you're going to use cos to multiply it, and if you go away from the angle, you're going to use sine. It actually asks us to put it in a vector format, and here's where I've got to remember about the fact that I've gone left and down. So down is the negative in the j direction, and left is the negative in the I direction. So when I do this, it will actually be minus 30.9 I minus 95.1 j. And obviously they are in newtons. Okay, so that's splitting the force into the two individual vectors with a lovely little shortcut that we're going to use throughout our mechanics from this point on.